Welcome to Software Engineering Daily. In the spirit of New Year's Eve, I'm republishing an episode rather than releasing some new content, giving myself a bit of a vacation. Today's episode is an interview with Vint Cerf, republished from the Quoracast, which is a podcast I was more heavily involved with in the past. Vint came on the Quoracast. He's an internet evangelist at Google, and he's also responsible in part for developing TCP/IP. So he's kind of a legend in the development of the internet. Our conversation was super interesting, and I hope you enjoy it. I did not get permission from Google to republish this. I just didn't even email them and ask them. I didn't want to take any of Vint's time. I don't think they will care, but if somebody out there in Google land does care for some reason, please email me. And to all the listeners, I hope you really enjoy this show. Happy New Year. Vint Cerf is Chief Internet Evangelist at Google. He contributes to global policy development and continued spread of the internet. Vint, welcome to the Quoracast.
Oh, thank you. It's a pleasure to be here for the first time.
I want our discussion to focus on the future because you are uniquely equipped to talk about the lessons of the past that will help us build the future. What will the world look like in 5 years?
Well, I wish that my visibility was as good as you seem to think it is, but I'll be happy to tell you what the trends are. The first one, of course, is that there's an increasing amount of access by way of mobile. So radio access is going to be increasingly important and common and at higher speeds. But it's important to recognize that all these radio connections ultimately have to go to ground. And so getting optical fiber in places to carry large quantities of traffic is equally important. Google is contributing to that in some cities in the U.S. and, in fact, some in Africa. We're putting in gigabit per second services. That is to say, gigabit at the edge. Of course, the interior is running at even higher speeds. So more mobile, more radio access, more speed is part of the trend. The next thing is that more and more devices will be part of the Internet's environment. And so although the question was, where is the web going? I think I have to answer, where is the Internet going? Since the web itself is just one of many applications of the Internet. Indeed, however, as the Internet of Things evolves, there are going to be an increasing number of devices that actually will serve web interfaces, partly because of the convenience and the significant penetration of browsers that people are familiar with using. So that is a scary prospect because large numbers of devices being part of the Internet leads to questions about safety, security, and privacy. We could explore that further, although I don't know how much time you want to spend on that.
Sure. So what are the big decisions there? What are the big inflection points around that security, and what are the bottlenecks around getting the world completely connected?
So the two things I would say are, by the way, getting everything connected may or may not be a wonderful thing. I mean, the neat thing about the Internet is everything is connected, and the not so neat thing about the Internet is everything is connected. So on the Internet of Things, the first issue is strong authentication, technology that will allow a device, which is part of the net environment, to assure that it's only communicating with devices that it recognizes is very important, and that's going to require the introduction of two-factor authentication and other kinds of strong authentication mechanisms that are built into the devices and the software that animates them. The second thing has to do with the ability of the user to be correctly identified as a party that should either have access to the device, to be able to control the device, or get information from it. And to illustrate the conundrum, imagine that you have webcams all around the house and your intent is to be able to use them when you're away just to make sure that everything is okay. You probably don't want a criminal to have access to that same capability because they could figure out that you're not at home. On the other hand, if there was a fire or a security alarm goes off, the police or the fire department might very well want to see what's on the webcams in case there's somebody in the building who's unconscious and needs to be cared for. So here you have two examples where, in one case you want things to be accessible and the other you don't, and being able to tell the difference is pretty tricky. So I think we're going to live through a period of time when a large number of devices that we become increasingly dependent upon will have potential privacy, safety, or security limitations. And some of your listeners may have run into reports about automobiles being hijacked remotely. The headline I worry about is the one that says 100,000 refrigerators attack Bank of America. And this is not a crazy thought if someone manages to take advantage of the processors that might be on board an internet-enabled refrigerator and outfit them with to do everything that it's supposed to do for the refrigerator and then a little bit more, like, mount a denial of service attack or distribute Trojan horses and things like that. So we have a rather fragile and bumpy future ahead. People like me and others hope that we can keep ahead of the game, or at least try to keep up with it and the risks that may arise. Because in the end, most of us think that these devices will make our lives more convenient, but not at the price of safety, security, and privacy.
And the bumpy road ahead that you described, do you think it looks more like a series of small incidents, relatively small instances where maybe you have some small denial of service by refrigerator, or some occasional hacking of a vehicle that results in the death of 5 or 10 people? Or do you think there will be some sort of catastrophic 9/11 scale event that it will take to really wake us up or have an inflection point? Or is this the wrong narrative to delineate?
That's a very, very good question. And one could even argue that on the grand scale of things, even the 9/11 incident, in just looking at sheer numbers, is not as bad as the number of road kills that occur every year. On the other hand, it certainly had a gigantic impact on policy. So I think the answer is unlikely that a gigantic, global or regional catastrophic event will cause huge change. And the reason that I'm saying that is that we've had so many reports of major invasion of databases, and most recently at OPM, for example, and somehow we don't seem to be responding very well to that. Frankly, I'm hoping that some of those incidents will, in fact, make us think twice about how to design and build and use these systems, which means that we as consumers have our part to play to make these systems more safe.
It sounds like the things that worry you, that maybe keep you up at night, are a lot more, they seem close to the types of problems that we encounter day to day, rather than the types of worries that Elon Musk and Stephen Hawking have about artificial intelligence. Would that be accurate?
So, I think as far as we've gone, yes, I think that's accurate. Let me say a little bit about artificial intelligence. It turns out that we make regular use of things that we would have called artificial intelligence, 20 years ago. I mean, when you do a Google search, you are exercising an enormous number of cycles and a certain amount of Bayesian arithmetic and a bunch of other things that make the system appear to be nearly intelligent, because it retrieves pretty much what you're looking for. Not as well as we would like in the long run. We'd like to have conversations with our computers to explain what it is we're trying to do and have them understand that and help us out. I think that artificial intelligence for the next decade or two will mostly be seen as assistive technologies that help us do things more effectively, as opposed to scary robots, armed with lethal weapons. On the other hand, I will accept the concern that to the degree that we give software autonomy, the ability to act autonomously, regardless of whether it's artificially intelligent or not, we should be worried about that, because bugs in software are still with us. And so giving software the ability to do things without human intervention can also lead to hazardous consequences. And I would have to say this goes all the way up to and including things like, an elevator's control system. There are lots of stories of people getting stuck in elevators because the software didn't work right. So I think that I'm much more worried about the run-of-the-mill software that we allow to make decisions on our behalf than I am about the sort of fictitious artificial intelligence golem kind of narrative that seems to animate both Elon and Stephen Hawking.
Have you looked at blockchain technology at all?
I have, and I'm glad that you asked the question in that way, as opposed to asking about Bitcoin, because Bitcoin is a specific instance of blockchain technology. I haven't been very impressed by the implementations of Bitcoin. Do your listeners know that you have a cat which is climbing on the back of your head right now? This is actually astonishing. Ladies and gentlemen, if you can't see this because you're listening to this, it's one of the most amazing cat events online on the internet that I have seen in a long time. This is very impressive.
I meant to close the door that my cat was behind previously, but I forgot to, so now the cat is, so he's behind me on the chair. He's accompanying me. My cat is also interested in blockchain technology.
Okay. So this is really amusing. I'm sure keep a straight face and the rest of it. So the blockchain idea is actually quite a powerful one because it's a way of essentially building a distributed ledger. And the argument is made that if enough distribution is done and enough replication is done of ledger entries, that it would be very hard to lose information and hard to fabricate a false transaction. I think the jury is still a bit out on the mechanisms that are used to compensate people for running the blockchain. At the moment, there is something called Bitcoin mining in the Bitcoin case, and you are rewarded with Bitcoins for having run the ledger program. But apparently, it consumes a fair amount of computing power, and there's a lot of question in my mind whether that's the only way in which to demonstrate work in compensation for having executed a part of the blockchain. I'm frankly hoping there will be other business models that will permit the blockchain idea to be implemented. The last thing I want to say about this is that the attraction of anonymous currency and anonymous transactions may be high in some quarters, but from my point of view, it's a risky proposition. I worry about the value. In the case of Bitcoin, we've seen the value of Bitcoins oscillate pretty dramatically. They're not rooted in the banking system, which some people see as a benefit. I will argue that it is a deficit and that I'd much rather have a regulated environment for transactions rather than a completely unrestrained one.
I know you said that was the last thing you wanted to say about blockchain, but I do have one question if you have thought about this at all. Do you see blockchain technology as providing any sorts of solutions to the types of problems that you mentioned we might encounter upon having more intense global connectivity?
I don't think so, and your listeners may actually respond differently than that, but I don't see that the blockchain necessarily deals in some good way or powerful way with the whole problem of a highly penetrated environment in which, I don't mean penetrated in the negative sense, but rather just lots and lots of devices that are online. It's not obvious to me that blockchain will be particularly useful. What will be useful, however, is strong authentication mechanisms, because that's the way in which we can inhibit certain communication if it should not be permitted.
Well, the notion of authentication meets blockchain might be something like if we think we have a malicious node on the network, the blockchain allows us to more efficiently declare, this is a malicious node. We can declare as a consensus, we are suspicious of this node, therefore we will not trust it.
Well, this gets us into the Byzantine generals question, as some of your computer science listeners may know. And I take your point. It's this K out of N thing that you have to think your way through, though. And then the question will be whether the blockchain parallel copying is sufficient, and can you get to the places that tell you that this is a compromised node or not? Let me say I'm a little skeptical about that, because the scaling and distribution would have to be pretty sustainable before you could declare that you want to rely on that K out of N solution. So I'm interested to see other implementations besides the blockchain specifically, besides the Bitcoin specifically, because I think blockchain has some advantages, but I'll be interested to see how some of these implementations work out.
Are you still thinking a lot about the digital dark age type of problem that you've discussed previously?
Yes, I am. I'm very much concerned about that. I had a very interesting meeting up at a place in New York called Chautauqua just a couple of weeks ago, and a big crowd of people were all very concerned about losing their digital images and other digital objects that they had worked very hard to create or to capture. This is a very serious problem, and I'm not persuaded that we have solutions in hand. The Olive project at Carnegie Mellon, it offers a very powerful solution for using virtual machines to run older emulated hardware and operating systems and applications. But we have to put a regime in place that allows the parties who are preserving this digital information to have access to if not source code, at least have access to executable code for a lot of applications, a lot of operating systems, and precise definitions of hardware implementation so they can emulate it. And then they may need to have permission to run these operating systems and applications in a cloud, for example, for third parties. And now we get into questions about licensing and other kinds of business models. So making this work has legal issues associated with it. And making it sustainable, that is to say that somebody goes to the trouble of saving the operating system software, saving the digital hardware design data, as well as saving application software on a regular basis and making it legal, is still to be worked out. So I think there's lots to be done.
I would like to talk a little bit about the engineering, but first, just to play the devil's advocate a little bit, does humanity have more information than it needs? Because there's this process of bit rot, and I'm curious why you see it specifically as a movement towards a digital dark age rather than a survival of the fittest bits.
Well, first of all, let me break this into three parts. The first part is that the physical media that we store things in have finite lifetimes. Some of them have theoretically very extended lifetimes. Claims have been made, 10,000 years, and in one case, 10 to the 20th years. On the other hand, the readers for those media may or may not survive all that long. Some of your listeners may have 5.25-inch floppies or 3.5-inch floppies that they have no readers for, and so we may lose the ability to read bits even if the bits are actually preserved. But the thing I'm worried about is, what do the bits mean? And now this goes to the other part of the question, the one you raised, which is, why save everything? Why isn't most information useless anyway? So why do we care? And the problem here is that we first don't always know which information is actually important. And you don't know a priori, and some historians will tell you some artifacts turn out to be very critical evidence, but you don't know that for a couple of 100 years or more. So that's one example. Another thing which I think is equally important is that if you wished to save something, whether it's useful or not, if you believe it is useful, then you should have a means to do that. And so part of my concern is that we don't have the means to preserve the bits and their meaning and the software that's needed to interpret them on a regular basis. And so we are bereft of the option. So even if not all the data we save is useful, if you thought it was useful, you should have the ability to save it in some long-term way.
And so one solution I saw you propose is something like a snapshot algorithm, where at a given time, if you want to save the information along with the medium used to read it, you take a snapshot not only of the project that you're working on or the application that you're working on, but you also take just a snapshot of the entire OS and everything end to end that is being used to read this software. Is that an accurate interpretation of one of your solutions, and are you thinking of any other solutions?
Well, it's not precise, although I did say exactly that. It was in an attempt to give people a kind of cartoon level model of the idea. And the idea was to take a digital X-ray of a computer that was running your application, imagining that the result of this fanciful digital X-ray was a copy of the hardware functionality, so detailed hardware operation, a copy of the running operating system, and a copy of the running application. Now, we all know that if you use virtual memory, that snapshot of physical memory may not have all of the operating system and all of the application in it, and it's been paged out on a disk or something. And so, this was a cartoon model. I still think, though, that the basic concept of capturing the operating system and the application software and the files that are associated with the object you're working on makes a lot of sense. And that's approximately the way that the Olive project succeeds in its implementation, which has been demonstrated for a number of operating systems and also a number of applications.
So to completely shift topics, just to close off, start to close off. So you've done research, or you've been involved in academic environments as well as private environments, like at Google. How does the research environment compare at these two types of places?
Well, I think that in the research world, I was just visiting the director of DARPA today, for example. It's a beautiful example of not just academic research, but really hard problems at the leading edge of what we're capable of doing. In those environments, you're often permitted to try things out that might not work. And I think that's a flexibility that research offers, especially if you have research funding agencies like DARPA and others that are willing to let you take very high risk on the expectation and hope of high payoff. In most private sector settings, you don't have that flexibility. You have products and services to get out the door. You have a business model that you have to meet somehow. You have customers that you have to serve. Google, by good fortune, is willing to tolerate a great deal of risk in exchange for the possibility of high payoff, just like DARPA. Its recent reorganization is a way of allowing it to continue to undertake those high-risk things while giving more transparency to the financial sector as to how much is being spent on the high-risk stuff and how much is being spent on the essentially bread and butter operation.
So to close off, could you provide my listeners with one piece of wisdom that you think they might find applicable?
Well, I think that two, if you don't mind. The
Sure.
first one is that if you really are concerned about saving digital objects in the long term, for those that are static, you might consider, for example, images or documents, literally printing them on some high-quality paper. And the reason that I suggest this is that we still don't have assurance that the digital objects will be correctly renderable even 10 years from now. Whereas we know that photographs and books on high quality paper last hundreds of years. And so I know that seems very backwards thinking, but to be honest, that might be the best way of preserving these things for the foreseeable future. The second thing is that we should abandon the belief that usernames and passwords are adequate for security. And wherever possible, your listeners should ask for or insist on two-factor authentication in order to protect themselves and perhaps also their employers' information. So those would be the two immediate things that come to my mind.
Fantastic. Vint Cerf, thank you for making time to come on the Quoracast. I really appreciate it.
Well, one is glad to be of service. I look forward to continued exchanges both on the Quora text site, and maybe I'll have a chance to listen to some of your webcasts as well.
Awesome. Okay, well, have a great day, and I'm glad you got to see my cat.
Thanks so much, Jeff.
All right, I'll see you later.
Bye for now. Bye.